Good morning, students. Welcome to the second part of our discussion. It's all about solving radical equations, part 2. Okay, before anything, we're going to learn what is the learning competency for this topic. We have solved equations involving radical expressions. For our learning objective, we have solved radical equation. Okay, analyze the illustrative examples below, then try to define an extraneous root. Example number 1, say x minus 6 is equal to the square root of x. So to simplify this, we're going to transform the right side of equation into exponential form, this one. So from radical form to exponential form. So this will be x minus 6 is equal to a quantity x raised to 1/2. Okay, after that, we're going to square both sides of this equation. So we're going to square x minus 6 and we're going to square quantity x raised to 1/2. So this will be like that. Okay, so we have now the square of a quantity x minus 6 is equal to the square of a quantity x raised to 1/2. Okay, so after that, we're going to apply the power rule, which is power to a power. That means we're going to multiply the inside exponent to the outside one. Okay, so when you multiply 1/2 by 2, this will be 2 over 2 for the exponent. So rewrite the quantity x minus 6 squared, then is equal to x raised to 2 over 2. And simplifying the exponent, we have 1, or the first power of x. So that we have x squared minus 12x plus 36 is equal to x. Okay, so when we simplify this part, this is what we call the square of binomial. The result, when we expand it, is x squared minus 12x plus 36. And it's equal to x. Why? Because 2 over 2 is 1, and to the first power is whatever the base is. So eliminate, or 1 is invisible. Okay, that after this, we're going to apply the additive inverse property to add x to the left and both sides of the equations. So add negative x to the left and also negative x to the right. Why? We need to eliminate x from the right. So when we add x to negative x, the result is 0, and that property is what we call the additive inverse property. So trying to add, this will be cancelled. The right side of the equation will be 0. And then adding negative 12x to negative x, the result is negative 13x. So our equation to the left will be x squared minus 13x plus 36 is equal to 0. Okay, using factoring form for this trinomial, we have to solve the equations by factoring. Then we have a quantity x minus 9 multiplied by the quantity x minus 4 is equal to 0. Okay, using a factoring form of the quadratic equation, the result is these factors. And then getting the value of x, or finding the solutions, we have two solutions. Our first root is equal to 9 and the second root will be equal to 4. So that's how to do it. That's all, and proceed to the next part. Okay, class, after getting the roots of the equation, which is 9 and 4, of course, we need to check whether it is a solution or one of these is the extraneous root. Okay, for our checking, if x is equal to 9, okay, now apply to our formula, x minus 6 is equal to the square root of x. Then substitute the value of x, which is 9. Okay, for here, x is 9, so x will be 9. And 9 minus 6 is equal to 3. and square root of 9 is 3. Therefore, our solution or our first root is correct. So our x minus 9 is correct. Okay, for another part of checking, we have to determine whether this root is a solution. So x is equal to 4. So for the second root, we have 4. So using the same equation, so we have x minus 6 is equal to square root of x. Then x will be 4 for this part. And 4 minus 6 is negative 2. Okay, square root of 4 is 2. And this one is negative 2. In short, our solution is not correct. And that first checking is the solution. Only 9 is the solution of the quadratic equation, while 4 is not the root. This is what we call the extraneous root. Proceed to our second example. The given is a cube root of 2x plus 1 equals cube root of x plus 8. So what we're going to do here is to transform to exponential form. Transform the left and the right side of the equation to exponential form. So the result will be this. Okay, now we have a quantity 2x plus 1 raised to 1/3 equals a quantity x plus 8 raised to 1/3. Okay, next, instead of getting the square of both sides, we're going to find the cube of both sides. Why? Because our index is cube or 3. So this will be getting the cube. And then apply the power rule. So this will be like this example. So we have the cube of quantity 2x plus 1 raised to 1/3 is equal to the cube of a quantity x plus 8 raised to 1/3. Now, after that, apply the power rule. The result will be 2x plus 1 is equal to x plus 8. Why? It's important to know that when you multiply 3 by 1/3 as a power rule, the result will be 1. 1/3 of 3 is 1, and then 1 is invisible when it will be the exponent of any base. So this will be this equation. And then after that, we're going to eliminate 1 to the left in order to remain 2x. So what are we going to do? Apply the additive inverse property. So we're going to add negative 1 to both sides. Add negative 1 to the left and add negative 1 to the right. Why? Because as you can see here, we can apply inverses, then this will be 0. Okay, this will be 0. So therefore, the left side will be, or 2x will be remained, and x plus 7 to the right side, because when you add 8 to negative 1, the answer is 7, and then rewrite x here. Okay, next step is we're going to eliminate x to the right, because our goal is to retain all constant term to the right. Okay, then after that, add negative x to both sides for inverses, or also additive inverse property. So now we have 2x minus x is equal to x minus x plus 7. Okay, what we're going to do is to cancel out this x minus x. That means this will be 0 to the right. Then 2x minus x is x, and then this will be 0. Then we write 7. Therefore, our final answer or our solution for this equation is 7, or x is equal to 7. So let us check. For our checking, use the original equation and then apply or substitute the value of x, which is 7, like that, for our x, and then simplify. The result is a cube root of 15 is equal to cube root of 15, because 2 times 7 is 14 plus 1 is 15. Also 7 plus 8 is 15. So they are the same. Therefore, that is the final answer, or our solution is correct for this equation. So next, okay, in order to know the level of your understanding, we have the activity. Okay, we're going to solve the following radical equations and box the final answer. Okay, we have 1, 2, and 3, 4 word problem for number 4. Okay, that's all for today, class. Thank you so much for watching.